Good afternoon and welcome to NASA's Kennedy Space Center in Florida for live coverage of the launch of SpaceX CRS-11, the 11th commercial resupply services mission by SpaceX for NASA to the International Space Station. This will be the 12th overall flight of a SpaceX Dragon to the space station. I'm Mike Curie and I'm joined today by Tori McClendon. Hello, Tori.
Hi, Mike. I'm happy to be here.
Glad you're here as well.
Thank you. Today's launch is scheduled for 5:55 and 53 seconds p.m. Eastern Daylight Time from Launch Pad 39A at NASA's Kennedy Space Center in Florida.
At the time of liftoff, the International Space Station will be flying high above the southern Pacific Ocean, about 254 miles up in space. The issue that we're looking at today as we approach liftoff, and we're at T-minus 39 minutes, 44 seconds and counting, is weather. It is the convective weather season here in Florida, and it is the time when the air is very moist, and we are fighting East Coast sea breeze and the West Coast sea breeze. They sometimes collide. When they collide, we get thunderstorms, and unfortunately, they have continued to form fairly close to the launch pad today. Launch Weather Officer Mike McAleenan from the 45th Weather Squadron has been briefing the launch team from SpaceX on the current conditions and the probability that things will improve. Right now, there are anvil clouds that have drifted back from the west over the launch pad and cumulus clouds from the storms that linger in the area. The percentage is really unknown at this point. The timing is what matters. We are about 39 minutes away from launch. It could be another hour or so before things have to keep an eye on it. We'll have a little bit more detail later on, and we'll be preparing for a weather briefing planned at this time at T-minus 15 minutes. But we'll keep you up to date on that. Tori?
Coming up, we'll provide you with an update on what this mission means to NASA. We'll hear from Acting Administrator Robert Lightfoot and International Space Station Program Manager Sam Shamimi for their perspective on today's flight. We'll also hear from SpaceX Vice President of Build and Flight Reliability, Hans Koenigsmann, and we'll delve into the science and experiments packed inside Dragon for their destination, the space station.
The countdown has progressed very well per the timeline so far. Collision avoidance coordination with the Eastern Range was conducted. We have no issues with that today. Check out of the autonomous flight termination system has been complete. Loading of RP-1 fuel began on time at T-minus 70 minutes, or about 4:45 p.m., and the loading of liquid oxygen began on time at T-minus 45 minutes, about 5 minutes before we came on the air.
This will be the first time most of the components and the weld structure of a previously flown Dragon spacecraft will fly again. The refurbished Dragon sitting at Launch Pad 39A previously flew on SpaceX CRS-4 September 21st, 2014 during Expedition 41. The first reflight of an orbital-class rocket occurred earlier this year when a SpaceX Falcon 9 first stage launched and landed for the second time.
If we are able to launch today, as we hope, at 5:55 and 53 seconds p.m. Eastern Time, Dragon, about 10 minutes after launch, will reach its preliminary orbit in space. It then will deploy its solar arrays and begin a carefully choreographed series of thruster firings to reach the space station. When it arrives at the station, Expedition 52 flight engineers Jack Fisher and Peggy Whitson of NASA will grapple Dragon. Fisher will use the space station's robotic arm to take hold of the Dragon, and after capture, ground commands will be sent from Mission Control in Houston for the station's arm to rotate and install it on the bottom of the station's Harmony module. Dragon is expected to spend about a month attached to the space station, returning to Earth with research and return cargo aboard on July 2nd. About 5 hours after Dragon leaves the station, it will conduct its deorbit burn, which lasts up to 10 minutes, and it takes about 30 minutes for Dragon to re-enter the Earth's atmosphere and splash down in the Pacific Ocean off the coast of Baja, California.
A couple of interesting facts about this mission. It is the 11th commercial resupply mission to the International Space Station. This is also the 100th launch from Launch Pad 39A. Previous launches include 11 Apollo flights, the launch of Unmanned Skylab in 1973, 82 shuttle flights, and 5 SpaceX launches. This is also the 27th launch from Launch Pad 39A to the space station. We previously had 25 shuttle launches and CRS-10. We are also scheduled to deliver nearly 6,000 pounds of experiments, crew supplies, and hardware to the space station. The Dragon spacecraft will be filled with supplies and payloads, including critical materials to directly support dozens of the more than 250 science and research investigations that will occur during expeditions 52 and 53. This is the 6th SpaceX launch from Launch Pad 39A. SpaceX CRS-11 was the first commercial launch from Pad A in February.
We're at T-minus 35 minutes, 5 seconds and counting. We continue to watch the weather. The weather radar is filled with lots of green rain and some red thunder in the area around the Space Coast, but we'll continue to keep an eye on that and hope that things will clear out. If we get off the ground today, we are going to be headed toward the International Space Station. There are lots of great things going on at the International Space Station. So joining us now is Amanda Griffin.
Thanks, Mike. So the Dragon spacecraft that we hope will launch today has both a pressurized and unpressurized section, allowing for a wide array of both experiments and payloads to be sent to the space station. Stowed today in the unpressurized trunk are several new technologies that we hope to test in space. NICER, which stands for Neutron Star Interior Composition Explorer, is an instrument that will measure neutron stars and test technology using pulsars as navigation beacons. MUSES, or Multiple User System for Earth Sensing, is an Earth viewing imaging platform created by Teledyne Brown. The platform will house high-resolution digital cameras and hyperspectral imagers. And ROSA is the Rollout Solar Array. It is a new type of solar panel that rolls open in space like a party favor and is more compact than current rigid panel designs. And here with us to tell us a little bit more about ROSA is the principal investigator, Dr. Jeremy Bannock. Dr. Bannock, thanks for being with us here today.
Pleasure to be here.
So as we saw from that short clip, ROSA is a pretty unique design. I know you have a model here with us today. Can you tell us a little bit about its design and its uniqueness?
Sure. So this is a 1/10 scale model, which I'll deploy for you here. So one of the unique factors with ROSA, or any large structure for that matter, is that they simply cannot be tested in the Earth's environment. They can't be tested in 1G. They're so lightweight and so large that they would just collapse under their own weight. So that's one of the reasons we need to go to space with this structure, is we need to be able to test it in the microgravity environment and also the extreme temperatures of space. We need to be able to measure the deployment behavior and also the structural dynamics, which is just how the wing responds to satellite maneuvers. What does that vibration signature look like?
And how long are you testing that?
So the experiment runs for 7 days. The majority of that time will be to test the structural dynamics.
And what are the future implications for this? What role might ROSA play in future space exploration?
ROSA has a lot of applications for future unmanned and for future unmanned spacecraft and potentially for stations. So one of the applications is to augment the current space station wings with additional power. So ROSA could unroll just right over the top of the existing wings. There are several commercial applications for reducing the mass of satellite TV, satellite internet, and communication spacecraft. There's also the potential for solar electric propulsion and the need for much larger wings to power these ion thrusters for interplanetary exploration or LEO geo transfer in the case of the DoD.
And that's exciting. Anytime you say solar electric propulsion, like that's exciting to me. And so you mentioned mass. So this weighs, I'm assuming, a lot less than maybe other current designs. So tell me a little bit about that. Like, how are you saving in mass? Which, of course, I think the number is for every pound that we take off of Earth's gravity, it's $10,000. So that's a huge savings if this can do the trick. So can you tell us a little bit about like the savings and efficiency of this?
Sure. So we're saving 20% mass over the traditional approach, which is rigid panel arrays, and 4 times smaller stowed volume, which is, in some cases, a much bigger impact. So we reduce mass by these high-strain composite structures. So these tubes here unroll under their own strain energy, so we don't need additional mechanisms and motors and springs and things. So we're able to cut a lot of mass that way.
Well, that's excellent. Well, I look forward to watching ROSA unfurl in space, and hopefully you get to go watch the launch here later this evening. So back to you, Mike and Tori.
Thanks, Amanda. This is Falcon Launch Control at T-minus 30 minutes and counting. And Mike, can you give us an update on where we are in the count?
You bet. We continue to watch the weather. That is our primary concern at this point. We're processing through the entire countdown. Launch Director Mike Taylor has verified that the launch and first stage landing danger areas are clear to personnel. The range coordinator has verified the eastern range is go for launch and landing. The Dragon controller has verified the Dragon launch terminal count auto sequence has started. At this time, Launch Weather Officer Mike McAleenan is briefing the Launch Director Mike Taylor again on the current weather conditions. Things just are not clearing as rapidly as they had hoped for. They're continuing to work through the weather go, no-go criteria to see whether or not we have an opportunity. We'll keep our ears on that and keep you apprised. We'll have our next official weather briefing, we believe, at T-minus 15 minutes. We're about 15 minutes from right now. So we're watching on the launch pad both Falcon 9 rocket stages, Stage 1 and Stage 2 with the Dragon on top. They were manufactured in Hawthorne, California and transported to SpaceX's rocket development facility in McGregor, Texas for testing. Then they were brought here to Kennedy Space Center, SpaceX's hangar at Launch Complex 39A, where everything was integrated. The Dragon spacecraft was loaded with its cargo, and the final major pre-flight test was a static fire at noon on Sunday, May 28th, when Falcon 9's 9 first-stage engines were ignited for 7 seconds with the vehicle securely to the pad, and everything went well. Earlier today, the Falcon 9 and Dragon were elevated to the vertical position for launch, and they've been powered up, all systems activated, computers have been turned on. Propellant loading continues without any issues. The RP-1 rocket-grade kerosene and liquid oxygen are being loaded onto both stages of the two-stage full-thrust Falcon 9 rocket. RP-1 and liquid oxygen combine to provide the power for the 9 first-stage Merlin engines, as well as the single second-stage Merlin on the Falcon 9 rocket. The plume that you've been seeing on NASA television during the countdown is gaseous oxygen being vented from the tanks. Please do.
Aside from today's launch, what other exciting things are happening around NASA?
Let's go to Derek Matthews, who has an update. Derek?
Hey, thanks a lot, Mike and Tori. I'm standing here on OSB-2 on this 5th floor terrace with this beautiful view in the background with the International Space Station Program Director for NASA headquarters, Mr. Sam Cimini. How are you doing today, sir?
I'm doing good. Good day for a launch.
It's a great day for a launch, and we're keeping our fingers crossed, hoping everything holds up with the weather. Just a couple of questions for you in a moment of your time, please. How will this commercial resupply mission support the International Space Station?
Well, the Space Station's mission is pretty broad. We're not only doing the research and technology development to take us humans to Mars and beyond low Earth orbit, we're also utilizing Space Station to advance research here in this country by private industry and by academia and other government agencies. So this spaceship Dragon is going to be bringing all the crew supplies and all the research and other supplies needed to do all those things.
Okay. How does the International Space Station support the agency's overall goals for deep space exploration?
So station is the most important element of that so far today. We're doing all the research necessary for the crew health and performance and all the technology and systems testing activities like the life support system and all the food preparation and things that'll be able to keep people alive and healthy and productive on long journeys into outer space.
Okay, I know you've been with the agency for more than 30 years. Tell me what is probably the coolest part of your job?
Well, the coolest part Even though launches are cool, it is not the coolest. First of all, I'm very humbled to work here at NASA, and the best part is working with people from around the country and around the world from all walks of life, from students to big cities to small towns to scientists to engineers, and my job at headquarters with our stakeholders up in Congress and in the White House. So I think working with people across the country and across the world is actually the really coolest thing.
Yeah, that sounds pretty exciting. I'm going to send it back to the press site where Tori and Mike are standing at. Tori, Mike, take it away.
Thank you, Derek. We are at T-minus 25 minutes, 4 seconds, and perhaps counting, but at this point we are going to be recycling the clock. While we were gone, we had another weather briefing from Launch Weather Officer Mike McAleenan, who briefed the launch director, Mike Taylor, and his team that there was a lightning strike in central Merritt Island within the last couple of minutes. The lightning flight rule requires 30 minutes for you to clear that before it's safe to launch. This lightning strike was within 10 nautical miles of the launch pad, and therefore, with only 25 minutes left in our window today, we're not going to make that rule. Plus, we also have not been able to clear some of the other weather criteria. So we're standing by for the official word and the notification. But at this time, the launch director has told the team that we will be setting up for a 48-hour turnaround because of weather, with the intent to launch on Saturday. Liftoff time would be 5:07 p.m. Eastern Time. But once again, we'll collect some more information and update you shortly. This is Falcon Launch Control. This is Falcon Launch Control. Recapping once again, weather has gotten us today. We had a pretty decent forecast that expected the weather to clear in time for today's proposed liftoff time of 5:55 p.m. However, things did not set up the way that they were projected. Storms formed closer to the launch pad and refused to dissipate and diminish. And with about 25 minutes left in the count, Launch Weather Officer briefed Launch Director Mike Taylor that a lightning hit in the central Merritt Island area within the 10 nautical mile cone from the launch pad was going to violate our lightning criteria. It would take 30 minutes for that to clear. There was not enough left in today's instantaneous launch window at 5:55:53, and therefore we have officially scrubbed for today.
NASA television coverage will begin Saturday, June 3rd at 4:30 p.m. Eastern Daylight Time for the next launch attempt of the SpaceX CRS-11 mission. Liftoff is targeted for an instantaneous launch window at 5:07 and 26 seconds p.m. Eastern Daylight Time. There is a 60% chance of favorable weather on Saturday. Mike?
Thank you, Tori. And with that, we will conclude our broadcast and look forward to joining you on Saturday at 4:30 p.m. This is Falcon Launch Control.